All right, so this week we will be talking about software and apps. A lot of this material we have already covered in some form or another in previous lectures, and there is a huge chunk of this that I'm going to skip because it's things that we're covering in the Wednesday lectures. A big part of this lecture is supposed to be dedicated to word processors, spreadsheets, and presentation software. In other words, Microsoft Word, PowerPoint, and Excel, or Excel and PowerPoint, rather, to keep it respective to the list. I'm not going to waste you guys' time with all that because, like I said, we're covering all that on Wednesday. It's your projects. So we're going to focus on everything else that this week's material talks about. So beginning with key types of apps. You can generally break down apps or application software in two different ways. The first way is in what they do. And to begin with, application software or apps are programs that you access on your computer or your mobile device that allow you to complete a specific task, whether that be writing a paper or building another program. You could edit images. You could do anything in general. And the four basic types of application software in terms of what they do, firstly is productivity software. This allows you to create business or personal documents, things like Word, Excel, PowerPoint. These are examples of productivity software, and one other that I'm going to spend a rather sizable chunk of this lecture on we'll get to later. Within your productivity software, you have graphics and media apps that allow you to access and modify digital media. This can be audio, video, images, etc., whatever. And that also falls into productivity. Personal interest apps it's software that lets you pursue your own personal interests. This can be related to volunteer organizations, or it could be art programs, which, as you can probably imagine, overlaps into productivity because something like Photoshop is a personal interest app, but it's also a productivity app. In addition, you've also got more casual entertainment related things like the Netflix app on your phone or any video games you might have installed on your computer. Communication apps, you're using one right now. Microsoft Teams is a commonly used example of a communication app. So is Discord my preferred communication app. I would love to be able to do these classes in Discord because you can share audio through that, whereas you can't do it so much with Teams. But here we are using Teams nonetheless because it's a Microsoft product. We get it prepaid thanks to the university, so why not use it? And lastly, device management apps. These allow you to manage the functionality of your device. It could be handling how data is stored, things like defragmentation, where it removes small chunks of empty space in your hard drive. It could be any number of things. I generally don't use third-party device management apps. I just use the things that are pre-installed on Windows, things like Disk Cleanup and Task Manager, which I can't be entirely sure if those fall under device management apps or system software, possibly both. It's kind of a weird gray area because it's a baked-in part of the operating system. Another way to subdivide all of your apps is how they're accessed. And we have, again, 4 options here. First off, local apps are ones that you've installed directly on your hard drive, as you have with Office 365 for this semester. Portable apps are things that you have running on removable media or the cloud. Photoshop, I mentioned earlier, More recent versions of it rely on the Creative Cloud. It's a software as a service type setup where the whole thing is run through and synced to the cloud. Also things that are on removable media, such as a flash drive or external hard drive. I have one on my flash drive that lets me apply ROM hack patches to Super Nintendo games, because I like to play old games like that, and I like to see what people have done to modify them. And I use a program called Lunar IPS that is run portably. Web apps allow you to access them through a web browser. That is how I am using Microsoft Teams right now. I prefer to use the web version of Teams rather than the desktop version. It's just more convenient, and it has enough for what I want to do. Does it run as well? No. Does it run well enough? Sure. But yeah, you also have a whole host of other options. Generally, most things have a web version nowadays, it seems. A programming suite that I like to use called Trinket for mainly Python programming. It is a web app. It does not have a desktop or mobile version, sadly, though. Speaking of mobile, simply put, these are either local, portable, or web apps that are accessed through your phone or tablet. Some key features of apps, things that you kind of already know, but we'll go over them anyway. They're represented on screen, on your desktop, or on your home screen as an icon or tile. This doesn't include all of your apps. Usually when you install something, it is automatically pinned to your desktop or your home screen, but that's not necessarily always the case. You may have to create a desktop shortcut like what I showed you guys a couple of weeks ago. And when they're on those screens, you either click or double click rather, or tap them to open them up. You can also single click and then press enter for desktop apps, but most people don't do that because it's kind of, a weird, inconvenient way to double click. All apps open up in their own window or windows. When it comes to art software, if any of you have seen or used one called GIMP or Paint.net, those both open multiple windows, one for the canvas and the main application options, one to show all the layers of your image, one for the different tools and brushes that you have access to, and one for the color palette. So that's an example of an application that opens up in multiple windows. But nevertheless, those windows are unique to that application. So Microsoft Word isn't going to open up Google Chrome inside of itself. If you click a link in a Microsoft Word document, it's going to open it up in your default browser. That has one key exception that most of you are never going to have to deal with, but if you're in computer science or computer information systems, you'll see this eventually, and that's through the use of a virtual machine. And the reason why these are an exception, you can open Google Chrome in a Linux virtual machine, and it will open a window inside that window. And the reason for that is because a virtual machine emulates the behavior of a computer through software. So that window for your virtual machine, whether it be VirtualBox or whatever the case may be, it is its own window, but it is a window representing a computer. And so that's why it becomes an exception to that rule, because it's running everything in this window. And I don't need to go over the fact that they have menus and buttons. You all know that. That's something that anybody who has used a computer for 10 minutes would know. And like I said before, some are available on the web and mobile apps, as well as desktop versions. It generally depends on the intent of the developer, who they intend to design it for. Some things work better on mobile or web than they do on desktop, so you may find some that don't have a desktop version. That tends to be quite rare, though. Talking specifically about mobile apps, these are generally accessed via the touch screen. Whether you use your finger or a stylus, and they'll have their own on-screen keyboard that they might use, or they might use your phone's on-screen keyboard, which is the usual case. Many mobile devices come pre-installed with apps. I am on my 5th smartphone, I think. I had an HTC Incredible, the Galaxy S3. No, this would be my 4th. An S3, S4, and now I have an A20. All of them have come pre-installed with apps. I don't think you're going to have an easy time finding one that doesn't have something on it. I feel like it's kind of a necessary thing. And organize apps into groups, naturally, represented by icons on your screen. Already mentioned that. And something that is more common to mobile devices than desktops and laptops is the App Store. This is generally where you're going to get all your programs for your phone or tablet, whether it be through Google Play or the Apple Store. In the last decade, that did become more common as Windows 8 introduced its own App Store, and that has since carried over into Windows 10. But it hasn't gained the same popularity that the mobile app stores have, because you can still very easily just go to a website, download an executable, and run it on a desktop, whereas that might be a little more inconvenient to do on a phone. Talking about native apps, a native app is an app written for a specific operating system and installed on a computer or mobile device. This is essentially another way of naming a local app. These can take advantage of specific features of an operating system, which is generally why they tend to be more powerful. They can take full advantage of what they're running on, as opposed to being limited to a web browser. And many of these may require an internet connection. Talking about Photoshop Creative Cloud, once again, that requires an internet connection, but it can run in an offline state. When doing so, it will hold on to the information that is being created and wait until the connection has been established to then synchronize or sync to the cloud. Another example of that, I use Steam, which tends to require an internet connection for games, but you can always run it in offline mode and it just won't use the Steam cloud to update your saves. Web apps. What was it that this slide wanted? Yeah, web browser. This is all stuff we mainly know. One thing I want to draw your attention to, partly because it's bolded and important, is responsive design. I don't want to go into too much detail on responsive design today because there is a lot to cover when it comes to responsive design. However, it should very well be explained in your textbook. Please read the material for that. And also, for those interested in web development, if you've ever wanted to create your own website, Free Code Camp has an entire certification track on responsive web design. And that will give you an idea of what that means. Designing for things like accessibility and different screen resolutions and shapes and other such things are all a part of responsive design. And it's a very interesting topic if you are into designing websites or even designing mobile apps or other things like that. You can take a look at that. Again, that's freecodecamp.org. I've mentioned it a couple times in previous lectures, but I really do recommend it for computer science, computer information systems, or just general technologically inclined people, especially at the freshman and sophomore level. as it's a very good introduction into computer science and will carry you through some of the more complex aspects. Many developers tend to prefer web apps because you don't have to design for a particular operating system. It's not, oh, this runs on Windows, but now I have to make a version that runs on Mac. No, this runs on Google Chrome. Google Chrome runs on Windows and Mac. So this will run on Windows and Mac, in theory. Sometimes there are issues, and that is generally where testers and debugging and other such things come into play. But regardless, it's much easier to develop a web app than it is to develop a desktop app. Let's look at some pros and cons of mobile web apps. On the positive side, they are easier to develop. Yet again, you don't have to worry about operating system conflicts as much. Because it's all done through an internet connection, your information is available on the go. Whether you're doing it through Wi-Fi or your mobile data, you have access to everything on the web app itself. And also you have access to voice input and smart keyboards and other such things like that that can simplify the interaction. Generally, just make it more user-friendly, provided the app itself is designed well. On the negative side, because these are easier to develop, a big reason for that is that they're simpler. And because they're simpler, they have fewer features and they tend not to run as well. And so you have the issues that we encounter in this course where, yes, the web version of Word is perfectly fine, but it's not completely serviceable for this course. I don't know why they make the point of poorly designed apps can turn people away. I feel like that applies to all forms of apps. I've used plenty of terrible desktop apps that just have a confusing layout, and I've decided I'd rather not. But I guess when you have the limited space of a touch screen, it can feel a bit more severe. It might place a harsher requirement on developers to think twice about how they're designing their app. And many people, including myself, find typing on an on-screen keyboard very cumbersome. My limited vision means if I have to use an on-screen keyboard for my phone for an extended period of time, I'm going to come away from it with a very bad headache. Because I have spent the last hour squinting and now my entire face hurts. So I hate using on-screen keyboards. I find it very clumsy and cumbersome. And yes, I could use, speech to text, but at that point, I'd rather just call somebody than try and text them with my voice. Some current trends in app development. Because these apps are much easier and also more constrained, mobile web apps that is, many developers prefer to develop the mobile and web versions first, because operating under those restrictions means they have to think very carefully about what they're doing. And once they get to the desktop version, it's not a matter of what they have to remove to make it suitable for a desktop application, but rather what they can add to extend the functionality of their app and generally make it nicer. Developers nowadays use a lot of cross-platform tools, whether they be hardware or software. And what cross-platform means is that people on different platforms can interact with each other. So say you have a program being developed in Python. Well, there are cross-platform tools to develop in Python using both Windows and Mac operating systems. Excuse me one second. And finally, before we move on to our next section, I believe, quick mention of m-commerce or mobile commerce. We talked about e-commerce a few weeks ago, and all this is mobile apps for e-commerce. It really doesn't get any more complex than that. You might have an Amazon app on your phone, or something else like that. And yeah, so m-commerce is e-commerce on a phone, is the gist that you need to know. And before we move on, because we're about to skip a whole lot of stuff and move on to something I find quite interesting, does anybody have any questions about what we covered so far? While I quickly check the time and get a drink of water.
We're good.
All right, give me just 1 second. So, talking about productivity software, as I've said, a lot of this is stuff that you're going to learn through the Wednesday lectures and through your projects and SAM exams. So I'm not going to spend any more time on these than we need to. What I will mention is some of the other options you might have alongside Microsoft Office. I apologize for that background noise. We use Microsoft Office, which has a lot of options besides Word, Excel, and PowerPoint. You also have Access, which is a database program. We're going to get to that in a minute. We're going to spend quite a bit of time on databases. You also have the Outlook email service, which is what Gem operates through. There's the Office Online web version, and also Outlook or OneDrive for your cloud storage. Similar to that, you have Apple iWorks, which is available on Mac, iOS, and has a web version, whereas Windows or Microsoft Office is on Windows, Mac, and the web. You've also got G Suite. If you've ever used Google Docs, Sheets, Slides, things like that, it's available on Chrome OS and web app. I'm quite fond of Google G Suite software in general. I don't prefer it to Microsoft Office, but when I need to put together something really quick, the G Suite tools are very nice for that. And finally, we have OpenOffice. This is a free alternative to Microsoft Office as far as desktop versions are concerned, but it does lack some key features. It is the only other one of the 4 listed here that has a database program, but it lacks an email client, a web version, and cloud storage. It's pretty much just desktop. It is a fine alternative. I find it really clumsy and glitchy at times. But if you need a free alternative to Office and you would rather use something installed on your desktop, because G Suite is also free, but if you would rather have something installed on your desktop, or if you use Linux, because this is also the only one available on Linux, then this is a fine choice. It will get the job done. I got through most of undergrad using OpenOffice. And so now we're going to skip over a bunch of things here because these are all covered in Wednesday lectures, talking about our presentation, word processing, and spreadsheet software. And we're instead going to focus our attention on database. I came to JSU with an interest in game design, and then I discovered database systems, and it is a topic on which I have been hooked for the last several years. I find it very fascinating how we handle data. So in general, what a database is a place to store vast quantities of data, however much you want, in a very organized fashion. There are a number of different ways to do it, and we're going to cover a couple of those. But in general, database systems have the same basic features. You can add, update, and delete data. You can filter, sort, and retrieve the data for forms and reports and other such things like that. You have access to all kinds of tools for tracking contacts or work orders or whatever things that you can represent in table format. In general, things are going to be represented as a table of some sort. And a database, if you can represent it as a table, you can put it into a database. So pretty much everything. And a lot of database systems represent all of this using structured query language, or SQL. And because tech people, including myself, like to force a pronunciation out of any abbreviation, we tend to call this SQL instead of SQL. But we use SQL to basically do everything in a database in many cases. Some do not rely on SQL. And the reason why we use SQL is there are two sides to database languages. You have DDL, or Data Definition Language, which is how you define your tables and specify what goes where, how tables connect to each other if you're using that kind of a database. And on the other hand, you have DML, or Data Manipulation Language. And what that does is that allows you to add, retrieve, update, and delete data entries from the tables that you have created using DDL. And SQL has commands to facilitate both of these. In fact, it is fully featured for both of these. Now, because databases tend to be quite large, and you generally make them because you want them to be accessed by multiple people at the same time, particularly when you're a business, databases live on a server. This may be a Windows-based server, it could be a Unix-based server, or whatever other operating system, but similar to a web server, databases are placed here because they are accessed by many people at once. And in addition to that, these can get quite massive. We're talking not just on the order of megabytes or gigabytes. We are talking possibly thousands of terabytes in some cases. Data can be further exported in a couple of different ways. Firstly, it can be taken to a spreadsheet to create visualizations such as charts or graphs or whatever you might want to put together for some sort of presentation. And additionally, you can export them to HTML for publication to the web. We will get more detail on HTML in a future lecture. That is the backbone of web design, and we are going to have a quick lecture on web design later in the semester. So be looking out for that. Most databases that you use nowadays are relational databases, also called Relational Database Management Systems, or RDBMS. I will be calling them relational databases just for the sake of brevity and clarity. Microsoft Access, which you have installed on your computer, is an example of a relational database. The one I use is another Microsoft product called MySQL. It, in my opinion, is even easier to use than Access. Access is clumsy and difficult to work with. Granted, I haven't touched it since 2009, but I don't expect it's gotten much better, given how much Excel and Word and PowerPoint haven't exactly gotten much better. They're just different than they were back then. And the key features of a relational database is that these tables, which we also call entities, which are made up of rows called records and columns called attributes or fields. These entities can be connected to each other using relationships. So say you are making a relational database for Walmart, just as a random example. An employee might belong to a department. And so we have mechanisms for defining that relationship. First of all, everything that lives in a database has what we call a primary key. And this uniquely identifies that record in whatever table it happens to be in. So an employee will have their primary key. A department will have its primary key. An employee will also have what we call a foreign key. And a foreign key is what draws the connection from employee to department. And that foreign key is generally going to be the primary key of whatever we want it to be related to. So I know I'm saying key a lot, and that makes things a little confusing. But to pull it back into something more grounded in real world, you have an employee who has their ID number. You have a department with its ID number. The employee's information will include the ID number of the department that they work in. And that is how it is represented in the database. And there are visual representations of this that we call entity relationship diagrams that very clearly mark out all of this to alleviate any confusion from all this repeated terminology, simply by having each table represented by a list and an arrow being drawn from one table to another to represent the relationship. And moving on from relational databases, because I know that was a lot to swallow, it's very easy for me to start gushing about database stuff, and I apologize for that, but it's, when you really dig into it, it's fascinating. Big data. This defines data that is even more enormous than what we've been talking about so far. Things that simply cannot be represented easily or managed easily by a relational database. You'll generally have things like unstructured databases or semi-structured databases for these. A semi-structured database might be something like XML, which you may or may not have seen at some point. And also an unstructured database might be something like MongoDB, which if you're a computer science or computer information systems major, I would recommend doing some research on both of these and getting familiar with them. Excuse me. Pardon me. But big data is generally so massive. It consists of billions upon billions, possibly, of small and large pieces of data. And these often require artificial intelligence programs to make meaningful analyses of them in a timely fashion, because there's no way you're going to have mathematicians or statisticians or other such math and science people crunch all of these numbers and come to something meaningful in a reasonable amount of time. So we need AI in order to do this. And finally, one last slide on two more, pardon me. This is mainly just some other terminology that we've talked about. I've already covered most of this, but I want to quickly mention reports and forms. A report is something that is user-defined, generated through a DML query, and it is how you can organize and store information outside of your database. So you create a query that's, say, going back to our Walmart example, we only want a table consisting of employee names, phone numbers, and job descriptions. Well, you can use DML commands through SQL to create this kind of report. And then a form uses the same sort of DML queries, but instead of an output, this is for input. So you'll have your form elements, your form controls, including text fields, checkboxes, radio buttons, sliders, etc., etc. And all of these are then collected into a query and loaded onto the database. And the reason we use forms is quite obvious. It's because we want our data to go in a uniform fashion. And by using forms, we can ensure that. So we want, say, all of these fields to be completed. We don't want any blanks being left. We want everything to be within a specific range. We don't want somebody entering like their birth date for their name. And so forms give us the power to control that and minimize the risk that someone is going to put in weird information. And one last thing to talk about with databases is security features. There are mechanisms within database systems that allow us to control who can see information and how they can see it. Can they change it? Can they remove things? Like, you may not want a customer service representative to see more than a customer's name and contact information. You don't want them to see payment information or their social security number or something crazy like that. So we use reports to create what we call views that restrict what can be seen by someone with a particular level of access permission. And those same people may not be able to insert any new data. They may not be able to change that data. All they can do is view it. And finally, one last type of software we're going to talk about is graphics software. We've mentioned Photoshop many times already before, but also you have Paint, Paint.net, my preferred, Paint Shop Pro, all kinds of options from the free to the expensive. Generally speaking, your images are going to be in one of two general forms, either raster graphics, which are based on pixels, which is what you're probably most familiar with, but there's also vector graphics. And the way these work is they use mathematical calculations to draw out lines to form an image. You can see on the right here, we have a close-up view of a part of an apple. On the left is vector graphic. You can see that it's very smooth. There's no aliasing from the pixels. Whereas on the right, you zoom in far enough into this image of an apple and you can start to see the pixels where it kind of blends from the red to the white, from the red to the black. It looks all very square and blocky. And that's a consequence of using raster graphics. They're much easier to work with, but when transitioning them from, oh, pardon me, I'll be right back. Yes, that's for the bed. All right, appreciate it. No problem. I do apologize for that. But as I was saying, raster graphics are much easier to work with because it's just a 2x2 grid of pixels. But when you're dealing with translating these digital images to something real world, like a button or a t-shirt, it's better to put them into vector graphics so you don't get those little tiny squares that just don't really look good when you look up close in some cases. And so that is a quick description of raster versus vector. Moving on to the general features of graphics software. You could use either a stylus or the mouse to draw whatever shapes you might want. You can freehand it. Just click and drag with a pencil or brush tool selected, and it's no problem. But you can also use shape tools to draw simple shapes such as stars or rectangles or arrows or whatever you might want, and you can use these to compose your image. You also have color tools, the color palette itself generally has access to the full RGB, that's red, green, blue spectrum. Those are your primary colors. And you set those values from 0 to 255 to choose your color. You have also, in some cases, access to HSL, which is hue, saturation, and lightness. And this accomplishes the exact same thing, but through a different set of parameters. So hue is sort of the basic colors, the saturation and lightness. It's a little more to go into than the scope of this lecture, but you're welcome to look into it. The responsive web design course on Free Code Camp talks about the difference between RGB and HSL. Additionally, you have filters to adjust the entire image. So you might want to apply a grayscale filter to make your image appear in black and white. You can apply text, and this is rich text. So you can specify the font, the size, whether it's bold, italicized, underlined, etc., etc. Rich text. I know we haven't mentioned this before, the difference between rich and plain. Plain text is just here are the characters and that is it. Whereas rich text includes all the different styling and sizing and other such options. And finally, you can crop and resize. Cropping, you've probably seen this before, is just select a portion of the image to keep and the rest goes away. And resizing, you can either resize the whole image to squash and stretch however you want it to be, or you can resize the canvas where your image lives. You could extend it to give yourself more room to draw or edit, or you can shrink it to fit the image better. Something else that this does not mention is the different selection tools that you generally have access to. One that is very powerful in many graphics editors is what they call the magic wand. And all this does is a cascading selection. You pick a pixel of a particular color, and it finds other pixels of the same or a similar color, depending on how strong or weak your tolerance is. A particularly strong tolerance will select more things in a wider range of colors, whereas a lower tolerance, it has to be closer to that. And you can select them within a flood type of mode where it will stop wherever it no longer meets the tolerance threshold. Or you can apply it to the whole image where everything that is close enough to what you've chosen works. And it's an incredibly powerful tool because I do things with game design. I work with sprites occasionally. I work with textures, and these are both images that need to be edited, and recoloring them often relies on using the magic wand tool to apply colors to specific points. And these are some common formats you'll find. BMP or bitmap. You also have TIFF. I've seen TIFF files used for fonts. That's probably the most common use I've seen for TIFF files. I haven't seen them for really anything else. JPEGs, they are your older image files, not as good of a color depth as more recent things like PNG. These are the more commonly used nowadays, full color depth and typically higher resolution, just generally a better image format. And then there's GIF, some also pronounce it GIF. These are commonly used to create quick animations without sound. And then you also have raw data files. I've never seen anybody use these. I don't know why, what purpose they serve exactly. I know that it says here that they're uncompressed and unprocessed, so I guess that could be a draw for it. It's like using a FLAC file for audio, which is a form of uncompressed raw data in audio form. So there's a possibility. But I have known some artists who work with a number of different image formats to do digital art. I've never known anybody to use .raw files. And finally, the different types of graphics apps. We've already mentioned paint apps, photo apps, but also video editors tend to come with these features in addition to their own enormous suites of other features for editing video and audio. Your video editing software, which can include Movie Maker or DaVinci Resolve or Premiere, whichever you would like to use, these tend to be very complex apps. We're not covering them here or at all in this class. Honestly, if you wanted to cover them properly, you would just about need an entire class to cover them. And also drawing apps, all kind of in the same ballpark. And they all have similar features. So